Let the total charge 2q be distributed in a sphere of radius r with a charge density rho equals to kr. Where r is the distance from the center. Two charges A and B of minus q each are placed diametrically opposite points at a distance a from the center. If A and B do not experiences any forces, then so in this problem, suppose this is our spherical charge distribution, and in this spherical charge distribution we have two charges which are placed at diametrically opposite end. So we don't know exactly that where the charge is placed, whether it is inside or outside point. So I'm considering, let's say this is the diameter, this is the center here. So let's say one charge, I'm assuming that it is inside, minus q, and this is minus q. So I will say that the electric field due to this entire charge distribution at this point is in this direction, and electric field due to this negative will be in this direction, and if these two electric fields are equal, then here electric field will become 0 and this particle will experience 0 force. So if I write the value of electric field here, so electric field due to a sphere at point P. So E will be written as here K Q enclosed by R square. In the question, the information is also given that it has a total charge of 2q. So I will say that q total is how much? That is 2q. So we will calculate the total charge that is enclosed within this region. Whatever be the total charge that is enclosed with this region, because of that here we will write the electric field as k q enclosed by r square. If I calculate the value of q enclosed, then here we will consider a spherical shell of radius r and thickness dr, and in that we will calculate the charge and then we can integrate it. So dq integration, dq is here 4 pi r square dr times rho going from 0 to r. So I will take 4 pi and this is r square dr, and rho is basically k times r. So this will become 4 pi k r cube dr. Let's integrate it from 0 to r. So this will become 4 pi k r raised to the power 4 by 4, that is pi k r raised to the power 4, and this is equals to 2q basically, sorry, not 2q, this is equals to q enclosed. And according to the question, it is given that for r equals to capital R, q enclosed is 2q, and 2q is nothing but pi k r raised to the power 4. So I can say pi k is how much? That is 2q by r raised to the power 4 here. So I will be using this result in the coming part of this discussion. I will be using this result here. Now if I write electric field at this point, then electric field due to a sphere, if I substitute the value at point P, then this electric field is going to be how much? So E will be K, Q enclosed is how much here? So Q enclosed is pi, and this K here, pi K r raised to the power 4, pi K r raised to the power 4, this will be a small r, pi K a small r raised to the power 4 by r square, and pi K I can write 2q r raised to the power 4, so k times pi K, that is 2q by r raised to the power 4, and this is r square. So we get here 2kq r square by r raised to the power 4. Now electric field due to minus q over there will be how much? Due to this minus q electric field at this position, if I write, then this is minus of, this is 2kq, this will be distance is 2a here, this distance is basically a, so I will write kq by 4a square. And it is saying that there the net electric field has to be 0. So for net force to be 0, for net force to be 0, E due to Q enclosed plus E due to negative charge should be equal. So this will be written as kq 2kq r square by r raised to the power 4, and here r is how much? Here r is because basically here a here, so this should be minus of kq by 4a square, this should be equals to how much? G. So here r is a because it is talking about this point, so here r is a here. So if I substitute the value of r in this given equation, then we will get 2kq a square by r raised to the power 4 equals to kq by 4a square. So k and k will cancel, q and q will also cancel, so we will get here as 8a raised to the power 4 equals to r raised to the power 4 here. And we have to calculate a in terms of r, so then I can further substitute here as a equals to r, and this is by 8 raised to the power 1 by 4. So a is nothing but 8 raised to the power minus 1 by 4 times r. A is nothing but 8 raised to the power minus 1 by 4 times r. So correct option is option third.